When a metal like copper is heated, it expands. Explain what happens to the metal particles as the solid metal expands. The particles of metal in solid state are tightly packed and close to each other. On heating this metal, the particles gain energy and they start vibrating randomly to move away from each other, and hence expansion of metal is seen. Explain why diffusion is faster in gases than in liquids. Diffusion is dependent on two factors. One is the mass of the particles and the other is the temperature. The particles in gaseous state are at higher temperature and has more energy. Hence, the diffusion in gases is faster than in liquid state. How is the movement and arrangement of the molecules in a crystal of nitrogen different from those seen in the gaseous state of nitrogen? The molecules in the crystal of nitrogen are closely packed and vibrate at its mean position. The molecules in the gaseous state of nitrogen are in random motion and free to move. A sealed container has helium gas and the pressure of the gas is increased if the temperature of the gas inside is increased by heating it. Explain. The particles of helium gas exert pressure on the walls due to its random motion and striking the walls of the container. On heating, these particles gain more energy and its vibration increases, thereby causing more bombardment and strikes on the wall of the container. This increases the pressure of the gas. Pressure and temperature determine the state of a substance. Explain this in detail. Any matter, that is solid, liquid or gas, when experiences an increase in temperature, they change their state. Example, from solid to liquid to gas on heating. Take ice cubes in a beaker or heat them slowly. The temperature increases and the ice melts to form liquid. Heat this liquid further, it will become steam. On lowering the temperature of any matter, show change in their state. Example, gas to liquid to solid. Take the steam that is coming out of boiling water and allow it to cool down. It condenses to form water, and on further cooling of this water, we get ice. On applying pressure and reducing temperature, we can liquefy gases or change them into solid. Example, take carbon dioxide gas, reduce its temperature and apply lot of pressure on it so that it changes into solid carbon dioxide called dry ice, which is used as refrigerant for cooling. If the pressure on it further decreases, it directly changes into gas. In LPG cylinders, the petroleum gas is first cooled and further lot of pressure change is applied to it into liquid state. While using this LPG, we release the pressure exerted on it and hence it comes out in the form of gas. Explain, giving examples, the various factors on which rate of evaporation depends. The rate of evaporation depends on the following factors. Surface area. If the surface area is increased, the rate of evaporation also increases. To dry the clothes, we spread them to dry faster. Tea in saucer cools faster than in a cup. Temperature. If the temperature is increased, the rate of evaporation also increases. Due to increase in temperature, the particles gain more kinetic energy and change their phase from liquid to gaseous. Water will evaporate faster in sun than in shade. Humidity. It is the amount of water vapor present in air. The air can hold definite amount of water vapor at a given temperature. If the amount of water vapor is high in the air when the rate of evaporation decreases on hot and humid day, desert coolers are not effective as the air cannot hold any more moisture to get the cooling effect. Wind speed. With the increase in wind speed, the rate of evaporation increases. The particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Cooking gas is often stored and delivered. in steel bottles. Over a period of time, pressure of the gas in the steel bottles does not change. Air and helium are gases that are often used to fill rubber balloons. Over a period of time, balloons gradually shrink. Explain the observations. The molecules of gas exert pressure on the walls of the container. The steel container have a wall strong enough to withstand the pressure of the gas, but the walls of the balloon are not rigid and hence they shrink. The observations given below determine whether the changes described are likely to involve formation of new combination of matter or are physical changes. Analyze edge of towel hanging in a wet bath draws up water. The change is physical change. The judgment, no new substance is formed. A firecracker explodes producing noise, smell and smoke. It is a chemical change. The heat involved and new product formed is the scientific judgment. Pink colored copper tap becomes green over a period of time. It is a chemical reaction. New compound is formed is the scientific judgment. Glass of car windscreen gets all water droplets on inner surface. It is a physical change. No new substance is formed is the scientific judgment. Take 2-3 crystals of potassium permanganate and dissolve them in 100 ml of water. Take out approximately 10 ml of this solution and put it into another 90 ml of clear water. Take out 10 ml of this solution and put it into another 90 ml of clear water. Keep diluting the solution like this 5 to 8 times. Is the water still colored? Observation. Yes, the water is still colored, but its color has faded in each dilution. This experiment shows that just a few crystals of potassium permanganate can color a large volume of water. This is because potassium permanganate is made up of millions of tiny particles. Take a 100 ml beaker. Fill half the beaker with water and mark the level of water. Dissolve some salt sugar with the help of a glass rod. What do you think has happened to the salt? Where does it disappear? Does the level of water change? Observation. The salt gets dissolved in water. The particles of salt get into the spaces between particles of water. The level of water does not change as the salt particles occupy the intermolecular space between the water and molecules. Put an unlit incense stick in a corner of your class. How close do you have to go so as to get its smell? Now light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observation. To smell the unlit incense stick, one has to go very close to this incense stick to smell it. In case of lit incense stick, even if you are sitting at a distance, you get the smell. This is because the particles of matter on gaining heat energy start moving faster and vibrate, diffuse in all possible directions due to increased kinetic energy. Take 2 glasses of beakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undisturbed in your house or in a corner in the class. Record your observation. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours or days does it take for the ink color of ink to spread evenly throughout the water? The beaker in which ink drops are added, the ink diffuses completely in the water within 5 to 10 minutes. The beaker in which honey is added in water takes longer time for diffusion. This activity shows that viscous or dense liquid take longer time for diffusion as compared to the liquids which are not viscous. Drop a crystal of copper sulfate or potassium permanganate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystals to settle at the bottom. What do you observe just above the solid crystals in the glass? What happens as time passes? What does this suggest about the particles of solid and liquid? Does the rate of mixing change with temperature? Why and how? In the hot water just above the crystals, the blue color appears to be intermingling at very fast rate and gets diffused in the water. Within minutes, the copper sulfate dissolves in it. In the cold water just above the crystal, the intermingling of copper sulfate is not visible and the rate of diffusion is very slow in it. This shows that with the increase in temperature, the rate of diffusion increases. Take an iron nail, a piece of chalk, and a rubber band. Try breaking them by hammering, cutting, or stretching. In which of the above three substances do you think the particles are held together with greater force? It is very easy to cut the rubber band. The chalk piece also breaks into two pieces with hand. The iron nail is difficult to be broken into two pieces. This shows that the iron particles are held together tightly and need extra effort to break them. The particles of chalk and rubber band are not that tightly held and hence it can be broken easily. Take some water in a container. Try cutting the surface of water with your fingers. Were you able to cut the surface of water? What could be the reason behind the surface of water remaining together? One cannot cut the surface of water because the molecules of water are held by force of attraction and hand cannot spread or cut or break this force of attraction between the molecules. One cannot cut the surface of water because the molecules of water are held by force of attraction and hand cannot spread or cut or break this force of attraction between the molecules. Collect the following articles: a pen, a book, a needle, and a piece of wooden stick. Sketch the shape of the above articles in your notebook by moving a pencil around them. Do all these have a definite shape, distinct boundaries, and a fixed volume? What happens if they are hammered, pulled, or dropped? Are they capable of diffusing into each other? Try compressing them by applying force. Are you able to compress them? All the articles given, a pen, a book, a needle, and a piece of wooden stick, have definite shape, distinct boundaries, and a fixed volume. Above articles may break under external force, but it is difficult to change their shape. These objects cannot diffuse in each other, nor can they be compressed. All the articles have characteristics of solid. Collect the following: water, cooking oil, milk, juice, cold drink. Take containers of different shape. Put a 50 ml mark on these containers using a measuring cylinder from laboratory. What will happen if these liquids are spilled on floor? Measure 50 ml of any one liquid and transfer it into different containers one by one. Does the volume remain the same? Does the shape of the liquid remain the same? When you pour the liquid from one container into another, does it flow easily? Observation: if the liquids are spilled over the floor, these liquids will flow. Let us put in any container. It takes the shape of the container but the volume remains the same. On pouring the liquids from one container to another, the liquids flow easily. Take 300 ml syringes and close their nozzles by rubber corks. Remove the pistons from all the syringes, leaving one syringe untouched. Fill water in the second and pieces of chalk in the third. Insert the pistons back into the syringes. You may apply some Vaseline on the pistons before inserting them into the syringes for their smooth movement. Now try to compress the content by pushing the piston in each syringe. What do you observe? In which case was the piston easily pushed in? What do you infer from your observation? Observation: the piston is pushed in easily in the syringe containing air. The piston is pushed with very difficulty in the syringe containing chalk pieces. Inference: gases are highly compressible, followed by liquids, but solids are non compressible.